Hello everyone, I am Shubham Swaraj and today I will be talking about Dijkstra algorithm. Well, I know it sounds like a villain from an Avenger movie, but trust me, it's a beautiful algorithm to find the shortest path. Imagine you are at your home and you want to go to your favorite coffee shop. Obviously, you will take the shortest path available. That's exactly what the Dijkstra algorithm does for you. Though there can be multiple paths to go from one vertex to another. In graph, we consider these houses as vertex and the roads connecting them as the edges. As you can see, there are different length of the roads. Similarly, the edge has different values. This algorithm gives you the shortest path from the source vertex to other vertex. Now we will try to understand using this graph. So you can see this home is our source vertex and rest other vertex are B, C, D, E and F. Now we will find the other distance from the home vertex to the other vertices using the Dijkstra algorithm. The initial step what we need to follow is initializing the vertex. You can see that there are the directed edges. This edge from A to B, this is a directed edge. B to D is a directed edge. C to F is a directed edge, and so on. And each edge carries some values. Now, the first steps for the Dijkstra algorithm is initializing the node. The very first source node, we initialize it with 0. Because if you are at certain location, then how much distance you will take to reach that location again? Of course it will be 0 because you are standing at that particular location only. Now we will see this source is connected to which other vertices. As you can see that A is connected to B and D. So we will modify the distance of A and B as 2, A and D as 4. Since there is no direct path from A to C, as we can see, so the value for the C will be infinite. There is no distance from A to E, so infinite. And again, you cannot see a direct path from A to F, hence it is again infinite. Now, after initializing the node, the second step we follow is to go to the other vertex. Now we will see which vertex has the shortest path, the least value. So the B has 2 and the D has 4. So we will go to the B node. After reaching the V vertex, we will find the other vertex that are connected with the B, that is C and D. Now the second step is the relaxation. Now when we select the vertex B, we will find the connected paths, connected vertices. So you can see B is connected to C and B is connected to D. So we will update the other paths with respect to B. That technique is called the relaxation technique. So the C is infinite. C will become 2, 2 plus 7, that will be 9. So we will update the C with the value 9. Similarly, the D has the value 4. But as you can see that B, that is 2 plus 1, will become 3. So 3 is less than 4. So we will again update the value with 3. Now After relaxation, we will see which are the vertices left, which are the vertices that are not explored yet, that are not visited yet. So it's D, C, E, and F. So the value of the D is 3, the value of the C is 9, the value of the F is infinite, and E is also infinite. So among them, the D is the has the shortest value. So we will come to the vertex D. At D, we will again come to the D, update our node to D, and we will find the connected vertices from D. So there is only one connected vertex that is E. Now what we're gonna do is we will update the value of E with the 3 plus 3, that is the 6. This vertex will get updated. After updation, we will find the unvisited vertices again, the vertices that are not yet explored, that is C, F, E, the three vertices. The value of the E is 6, F is infinite, and C is 9. So the least value is 6, that is of the vertex E. So we will update our vertex and come to the vertex E. Now at E, we will again do the relaxation technique. We will see the sort connected vertices from the E, that is C and F. There is only two connected vertices you can see, that is F and C. Now 6 plus 2 will be 8. So we will update this vertex with 8. Again we will see 6 plus 5 is equal to 11. That is less than infinite. So we will update the F with the value 11. Now after relaxation, we will find the unexplored vertex. So the unexplored vertex now is the vertex C and the vertex F. The value of the C is 8 and the value of the F is 11. So we will go to the C vertex. At vertex C, we will see the only unexplored vertex is now left is the F vertex. So 8 plus 1 will be 9. And is 9 less than 11? Yes. So we will update the F with the value 9. And now every vertex is now explored. So we have the distance of each vertices from the source vertex, that was the A vertex. This is what Dijkstra algorithm is. Done and dusted. That is how simple this algorithm is.